And thanks, Malik, for the high praise there. So as mentioned, I'm Teresa Alves from Cloudflare. I'm a part of the Workers KV team. And today I'm going to talk to you about basically what we were doing over the summer after a big outage. So we're going to talk a bit about resiliency versus consistency, which was basically what we were solving as we have multiple data sources. So this is not working again, but I'm going to guess this one is. So I wanted to give you a small introduction to what Workers KV is, if you don't know it already. But first, I'm curious, how many of you know what Cloudflare Workers is? Show of hands. OK, pretty good, nice. But still, like for those without context, Cloudflare Workers is a serverless platform made for building and deploying some smallish applications on Cloudflare's global network. So if you know Cloudflare more as the CDN, as all the points of presence in the world, that's where Workers lives as well. And Workers KV is a binding, meaning something basically you can connect directly to a worker, basically with a click of a button. And it's the Workers key value storage. So also distributed, very easy to use with Workers, basically native to Workers. As you use it, like you can go to the dash and you see it right there, along with the other storage databases that you have for Cloudflare, and using it like it's a key value storage, right? So you put a key, you get a key. Simple enough, right? Seems very simple. So where exactly does Workers KV live? As I mentioned, like you have about 400 points of access now for Cloudflare, 400 data sources. So you can see them all here on the map, which I'm hoping is up to date because I took it from the website. And so Workers, the worker that you can create will exist automatically in all of these points. And so Workers KV will as well. But I mean, if I write something in one point of the world, it's not expected that the data is replicated over the 400 points, right? So there must be some kind of centralized access, some kind of centralized place where we have all the data stored, so it can still have consistency over the whole world. And then, of course, we have caching on a lower layer, so it's still performance. So you don't have to travel the whole world to get your value for your key. But now you may be wondering, OK, we have 400 points of access, but I'm telling you that there's a single point in the world that has all your data. That doesn't sound great, right? Like what happens if that point goes down, right? So what happens is it goes down, which is what happened in June of this year. We were unfortunate because at some point we were in a temporary state. We used to have 2 third-party providers that had our data, but as you can imagine, in maintaining both, we were having some consistency issues. And as KV grew, as the data grew, we started noticing more problems that were not noticeable at a lower scale. So as we implemented a new solution, we turned off the second provider. And of course, something happened. It went down. We were not expecting that. And so basically, our work over the summer was redesigning the whole KV architecture to make sure it does not happen again. That's not rely solely on third-party providers anymore. So yeah, then you can see it was less than 2 months afterwards. So this was 12th of June. It was 8th of August. So we were deploying already the solution with both providers. But this time, the second provider, it's our own. We made it in-house. We're not going to rely on third-party providers anymore. And this is a very simple schematic of what's happening now, basically, which, of course, this has so many blocks in there. But there's not enough room in this PowerPoint to draw them all. So there's your worker there. You just put a value to KV, and now KV connects to both the third-party provider and KVSP, which is KV storage proxy. It's basically the underlying thing we have now that actually has the data in our own infrastructure. There's more to read about that on the blog, or you can ask me if you want, but not going to get too much into this part now. But now you may be wondering, OK, you had problems in the past. Now you have 2 providers again. How are you writing to both providers? How are you ensuring that the data is in both providers, right? So there's a lot of things you can do here, right? Depending on what you value the most between availability, performance, consistency. So let's evaluate more options. So if you just want data to always be consistent, the best thing you can do, or the best effort here, is you can now looking a bit more at the JavaScript side of things, right? you can do just a promise.all. So you have the promise that writes to provider 1, the third-party provider, you have a promise that writes to provider 2. If you await them both, then it will necessarily write to both of them, right? And it will only return back to the client a success if only both of them are fine. But then again, okay, if we want necessarily them both to be okay, then the June incident will still happen, right? It'll still be one of them that fails, we will still return 500 to the client, and we'll still get messages from the CEO. And that's not great. So on top of that, even if everything's fine, or fine-ish, like now the time it takes to get you a value, it will still be the worst case scenario from both providers, right? Because you necessarily have to wait for both of them. So adding a second provider would substantially reduce performance. So we don't really want that. At least we shouldn't. So second option, we can raise the rights to both backends, right? And here you might expect me to do there the Promise.race, but that wouldn't really work here, because the Promise.race will also return if one of the promises resolves but is a failure. So here in particular what you want is a promise any. So if any of them resolves successfully, that's the one you want to come back. So this is very nice because now if there's an outage, it's seamless to the client. Like, okay, there's something that keeps working. You don't know what's happening in KV, but it's doing its thing. And then, but then this has, of course, some more consistency issues. So if I return a success to the client after the first one finished, but the second one did not, if I try to read it, I might hit the one that's not updated, right? So that's not great either. So we can try to think of a hybrid approach at some point to try to get them all together. And here we can look a bit at the Promise.race as well. So this is more related to the first approach that I gave you. So you still want to wait for them both, but maybe you don't want to wait for 3 minutes for them to fail anyway, right? So here what we're doing is we still have the Promise.all to write to both providers, but you put it with a timeout, meaning if there's something that's not working, if something is with degraded performance, at least the clients will not wait 3 minutes, whatever, for it to fail. So this is, I mean, it will still be serious, we'll still have problems, but it's at least somewhat of a middle ground. Or you can do something a bit more complex, that you basically race both of them, right? You see which one did not finish, and you give it some time for that one to resolve. Like after you know for sure that you have one resolved. So you raise the first one, see which one didn't work, and then you raise the second one with a timeout, right? I'm not telling you here exactly what should be done for your particular scenario, because, I mean, maybe you value consistency, maybe you value performance and the failover. It's kind of up to you what's best for you. And so when exactly should we use Promise.race, which is not that used comparatively to Promise.all or all settled, whatever. Like whenever I see things, it's always Promise.all, right? We want everything to be good. But in particular, I think it's good to implement this timeout logic. You can always have a promise that simply does a timeout. So you don't have to wait around for whatever it is that you're doing to break or to have some sort of other internal timeout that will take 30 minutes. You can instead just configure your own and not wait for the reply from anyone else. And then maybe, I don't know, if the packets got lost on the way, maybe the client can even decide to retry it. That's up to them. So, but then you also have like 3 other things that I remembered here. Of course, this is not an extensive list. You can kind of use Promise.race, but you can also use Promise any. As I was mentioning, Promise any resolves once one of them resolves successfully, and the race just races them. Whatever resolves first, whatever it is, it will return. So these ones, like if you just want to get the fastest response, no matter which one it is, no matter if it fails, maybe you're just also throwing an error for a 404, maybe that's fine. Maybe that's what you want. And then the advantage of the race, also here it's to implement the automatic failover scenario, as I mentioned before, which is also nice, but you can use, as I said, the Promise any. And there's another thing that's funny to think about, especially for web development, which is you can use this to interrupt some kind of loading. So the user can use it to interrupt some kind of loading screen, right? So you have a loading screen and you have a cancel button. Which will finish first, the loading or somebody being frustrated and just getting out of there, right? So that will work there as well. So a bit some things for you to consider for your own application, because again, I'm not here to tell you what to do. I'm just telling you, these are the options that you have, and here's how you can play around with them, right? So in particular, something that's very interesting, especially in distributed systems, which is, of course, the case here, because there's 400 points of access of Cloudflare and of workers KV. You need to consider the CAP theorem. And the CAP theorem states that a distributed system cannot simultaneously guarantee consistency, availability, and partition tolerance. So as I mentioned here, if you were using the Promise.all, maybe you were favoring a bit more consistency. If you're using the Promise Any or Promise.race, you're probably favoring a bit more availability. In case of KV, we're favoring availability. So we're using the Promise Any or whatever combination of things we have in that lower level failovers, but I think that's the baseline, because we have a system that's AP, so available and partition tolerant, and not CP, because KV is not a strong consistency database. We're an eventual consistency database, which means like each request, each read will still be cached for, I think, a minimum of 60 seconds. So if someone writes something in the States, it should update immediately for them, but if I'm cached in Lisbon still for 60 seconds, it will still take me 60 seconds to get that value back. So we're not really privileging that now, which does not mean that we're not doing whatever we can to make the data consistency all throughout the world, right? Which leads me to my next point. Like, I'm talking to you about Promise Any and Promise.all, but this is not the only way of getting your data consistent, and not the only way of using these types of things, even with the timeouts and everything else. For consistency itself, you'll probably need some other type of mechanism, some other thing that will actually see what failed, because even with the Promise Any, the second one can still fail, right? With the Promise.all, things can still fail, and it still wrote for the first one. So it's important to note that you will need some kind of mechanism to ensure that the data is consistent and that the data will be consistent after one of them goes down. And yeah, that's basically it from me. I'm trying to leave a bit more margin for you guys to ask questions. And of course, I'm selling here to apply to Cloudflare because I'm a bit biased, but I like it here. And yeah, if anything, if you don't want to ask me here, just I'll be around. But meanwhile, yeah, that's it.